Hey, this is Noah Aced, and I'm showing you my MATLAB final project code, which basically it plots the motion of some moving objects in a 2D space, affected only by the gravitational pull of each other. So you can kind of see the code here. Unfortunately, my screen's pretty squished, so you can't see a bunch of it at once, but there's my code. You can see it all in the post anyways. And I'll run it and show you how it works. So let's do a pretty simple run first. So I'll run it, and it'll prompt me to enter the number of bodies, which I would like to send in motion, so the number of moving bodies. Let's try just 2 to get started. And then it asks for if I want any static bodies. I'm going to say 0 for now, to keep it simple. Leave it at that. And then now it'll ask for the length of time which I want it to run for. I'm going to say 100 seconds, which in the code actually is 1,000 incrementations. Each increment that it runs through is, or each loop runs through is 0.1 seconds. So if I run that now, it will take a moment and then it'll create this. So this right here is the visual generated for this motion. Oh, just not go like that. It's better here. I believe the red points are the starting locations. And then, is that right? Yes, red is starting location, I believe. And so these are where it started, and they attract each other. And also they start with some random velocity, so you can see that they start off not moving towards each other, but then they get pulled around towards each other and end up making this full motion. So that's for 2 objects moving in space. I can run it again this time, and let's say we want 3 objects instead. So 3 objects, I'll still say no static objects. And once again for 100 seconds. So this time it's a much more chaotic motion. You can see there's a lot going on here, but you can follow each of these individually if you want. You can use your mouse to follow them. And yeah, they kind of just take this crazy little journey around, starting up in this corner and ending down here. You know, this happens a lot if you have a few objects. They'll kind of like follow each other along. The overall mass moves in a certain direction. But let's say now, well, first off, let's try doing, like, if you want, you can try doing like a bunch of objects. It'll take a bit of run, but let's try that. So 20 objects for 100 seconds. It'll take a bit, and yeah, it's kind of a mess, but the code really can do it all. And it looks pretty neat if you zoom in. You can see a bunch of movement. It's just very hard to follow. But yeah, there you go. Now, let's try looking at, let's do 2 objects again. But this time, let's add in a static object. So I'll say, yes, we want one of those. And it asks for the mass of it. Every moving object always has a mass of 10 to give you a scale for it. So let's add an object also of mass 10. Enter in 10. And once again, for 100 seconds, I find it's a good time to kind of see the overall movement. And if we run that, there you go. So this object right there, that is your static object. The size of the circle kind of represents the overall mass of it. It is a point mass, but the size gives you a visual indication of it. So there you go, it's right there. And yeah, it's what you expect. The objects are pulled towards it and to each other. Let's see. I'll run again this time. And this is another aspect of the code, is that if I say, once again, 2 objects, and if I want to do 2 static objects this time, you'll notice that it asks, okay, it's kind of cut off here, but I'll read through it. Would you like to specify the masses of your static objects, or would you like them to all be the same mass? So basically, you can enter 1 if you want to say this object is mass 5 and this one's mass 15, or you can hit 0 and then enter in the mass for all of them at once. So I'll say 1, and let's have one of them be size 5, mass 5, and the other one be, let's say, 15. And then I will run that for, once again, 100 seconds. And, oh boy, a lot happened here. So you can see there's 2 objects. One of them is right here. And that one didn't get much attention because the other one, which is a lot heavier, up here, really pulled them all in. And you can see it, it's right there. It doesn't look all that big, but if you compare it visually to the other one, it actually is a lot larger. So there you go. And then if I wanted to, I also could just go, okay, let's have, well, actually, to make it more obvious, I'll do this. Let's say 0 objects, but I'll have static objects. I'll have 3 of them. And I'll make 1 5, 1 10, and 1 15. 4, it doesn't matter. I'll do 1 second. There you go. So you can see they're all different sizes. And I'll do it again. And this time I'll do, just to show that it also can work this way. Let's say I throw in 10 body, no, let's say 10 bodies. Let's do just 2 bodies, sorry. 2 static objects, 0 I'm going to enter this time. And now I'll enter just one value of 10, and that'll choose every single static object's mass. And then lastly, I'll enter the time, 100 seconds. So there you go. This time they're the exact same shape because I hit 0, so it's all the same mass. Last thing I'll add is that this, I didn't include this in the code because for certain combinations of moving and static objects can be a bit of an issue. But if you wanted to, you can go to this line right here, line 116 in the code, enter a new line, and just type draw now. Sorry, draw now. And if you do that now, let's see what happens. So if I run it again, I do 2 bodies for 0 static objects, 100 seconds. And what will happen is that it will actually draw the points as it goes. And so you can kind of get an actual visual motion to your pieces. So run it, you actually can see them moving in semi-real time, which is pretty neat. So I recommend messing around with that if you want to. Again, I didn't include it because for certain combinations of things, it can be a bit messy. But especially for a few objects, it actually is really neat to see a kind of approximation of their velocity and how they're moving. And that is pretty much my code. Thank you for watching.